Oh hey, I didn't see you there. You caught me working on our one-man band. While you're here, let me explain this to you. The goal of our project was to create a one-man band. Sort of like you see a hobo out on the streets with pots and pans and cymbals. But our one-man band is better. Our one-man band allows you to play multiple instruments even at the same time. It has record and playback functionality, and you can even bend the pitch of a note to make it go sharper. Our design basically consists of three components. You have the wearable design, which allows you to play the instruments. An intermediate design, or an intermediate part, that is responsible for recording and playback, as well as some of the more higher level processing power. And a final part, which essentially outputs the music.
Hi, I'm Michael, and I handled the hardware and the software for the input part of this project. So the first part of this project is to get the user input, basically how do you play the instrument, and that's accomplished using all of this stuff here. The first part of the 6 parts of this is this board here, which consists of a PIC-18F microcontroller and a lot of supporting circuitry. On this board you'll see also a capacitive keypad, which serves as a drum pad. Whenever you press a key, you'll get a drum sound according to which instrument you selected elsewhere in the system. So if I press a key, we get different drum instruments played. Next, we have a custom capacitive keypad that we constructed ourselves. It has 11 keys and 12 LEDs. This is the main instrument for the project, and it is essentially intended to be used as a keyboard, although you can select from a couple dozen different instruments. So the main parts of this board are the keyboard, which interfaces with a capacitive touch sensing chip, and the LEDs, which communicate through I2C, which is a 2-wire serial protocol, with the main PIC board. When you press a key, it generates an interrupt, which the PIC reads and determines which keys have been pressed or released. When it determines what keys have been pressed or released, it then tells the individual LEDs to light or not light, depending on if you're pressing it. So when I press a key, not only will we get an instrument sound, but also the 2 LEDs on either side of the key will light up. And then when you release it, everything stops. You can play as many of these keys as you want to at once and release them in any particular way you want to. Doesn't sound great, but it works. The next part is this accent instrument, which is intended to be used as, say, a cymbal crash or a cowbell, and it's just a push button that's mounted in between pieces of perf board and a couple springs to make it bounce back. When you press it together, you'll get the sound of whatever instrument you selected elsewhere in the system. So right now it's set to be a cymbal. Every time you click it together, you get a cymbal crash. Emory mentioned in the intro, you can also pitch bend notes while you're playing. Inside of this glove is a resistive flex sensor. The way this sensor works is it changes its resistance based on how far you bend the finger. It's connected to the PIC board here, and it's sampled 60 times a second by the PIC's analog to digital converter. When you press a key and then bend your finger, you'll hear the pitch go sharp and flat and sharp and flat as you bend it and release it. So it also works on the entire channel, so whichever key or keys you're pressing at once, all of them get pitch bent. The final part is the recording and the playback functionality, which is handled by this pedal here, which is essentially just 2 push buttons, arranged so that you can only press one of them at a time. Rob will discuss that in a few minutes.
Hi, my name is Rob, and I was responsible for all communication to and from the Kyle board. So the Kyle board is sort of the central processing area of our system. It connects the input PIC to the output PIC. It communicates over I2C. The Kyle board is actually the master, and the two PICs are the slaves. So what happens is, since the input PIC is a slave, it can't actually let the Kyle board know when it has new data to send to the Kyle board. So every 10 milliseconds, the Kyle board actually pulls the input PIC and asks if there's any new data, any new MIDI messages, or anything that needs to be sent to the Kyle board. So that happens every 10 milliseconds. And then within the Kyle board, one of several things can happen. If it's in the mode like it is right now, where there's no playback or recording, it just forwards that MIDI message straight to the output PIC, where it'll send that to the MIDI synthesizer and actually create music. Using this cantilever pedal here, we can actually play back notes that you've recorded. So Skunkers McSkunkson is going to help me here. He's going to hold the cantilever pedal in the record position. I'm going to play some notes. Go ahead. So if you notice, you can play notes on the keyboard as well as drum notes. So you let go of the recording, and then when you press the play button or press forward on the cantilever pedal, it'll actually play back what you recorded, and it'll actually keep looping through, so you can create a sort of underlying beat if you want. Now, the way it performs this is there's a small buffer in memory which holds the MIDI messages, but for larger numbers of MIDI messages, it actually writes to an SD card, and that was our API contribution for the project. So we wrote an SD card driver for the Kyle board, so it actually talks to this mini SD card right here, and it has 64 megabytes of memory to write to, so it pages in and out of the memory card, so you have basically unlimited storage for recording your MIDI messages.
The user interface is a fairly simple interface. It's textual based, controlled by the joystick on the Kyle board. You basically have 3 categories of instruments you can choose from. You can choose a drum instrument, which is controlled by one of the capacitive touch keypads, an accent instrument, which is controlled by the push button, and a group instrument, which consists of 8 different instruments, and that's controlled by the other capacitive keyboard. To select these instruments, you have these menus: drum, accent, and group. So for example, if you want to select a group instrument, you go through here. Green denotes a currently selected instrument. Red denotes the current line that you're on. So you can go to a line, press it, and now the organ instrument is selected. And as you can see, this is in the main menu. You can see that the group instrument is now organ. Hi, I'm Emory, and I was responsible for the output PIC. The output PIC takes what we play and outputs it to these speakers. Another important part of it is it powers the entire project. It does this via the train bus, which is a combination of power, ground, and I2C lines. It consists of 2 main components: a PIC18F microcontroller and the MIDI synthesizer. The MIDI synthesizer really simplified this project because it takes in a byte and, according to the MIDI protocol, produces a sound. This is done via a 3.5mm headphone jack, which connects to these speakers. The main purpose of this PIC18F is this receives an I2C message, but this guy needs a UART message. So this PIC18F basically takes in this I2C message, parses it out, sends it over UART, which is an asynchronous receive-transmit bus, very similar to I2C. And it sends it out via UART to the MIDI synthesizer. An important part of our project was the wearable design. This made it truly one-man bandish. Rob's been so nice here to model it for us, so I'll walk through and explain it. Over here is sort of the input portion. We have the glove, which houses the flex sensor. Mounted here on the arm is a capacitive touch keyboard. It's responsible for playing the group instruments. And a capacitive touch pad, which is sort of responsible for our drum instruments. All this stuff is mounted to this shirt. The shirt basically just keeps everything as neat as possible. It routes the wires through the inside and down the back. Down here is the accent instrument. This is mounted here so you can sort of have the whole cymbals between the legs action. And then further down is the cantilever pedal. As we spoke about before, this is responsible for record and playback.
So, using the cantilever pedal, we can actually record a drum beat in the background and then play whatever we want on top of that looping. So I'm going to start recording by tilting my foot back. And then, when I tilt my foot forward, it'll actually loop through what I just recorded. And then, what I can do is I can play on top anything I want. More drums on the keyboard. And then, if I want to change, loop through that group of instruments that we selected on the Kyle board, activate the tilt sensor, and it's a new instrument. Also, when you're playing the keyboard, you can activate the flex sensor and it'll actually change the pitch of the note. And you can also hit your knees together as your crash instrument.
All in all, we're really happy with the way our project turned out. Everything came together really nicely. It's proven to be very reliable overall. The communications will run for days at a time with no issues. However, if we could go back and do a few things differently, there definitely is room for improvement. For one thing, there's a lot of wires running everywhere. Adding wireless capabilities would make it a little less cumbersome and just generally a little more user-friendly. Secondly, the vibration sensor that we wanted to use initially didn't really work, so we ended up going with the push button for the accent instrument. But other than those two things, if we had to go back, I don't think we would change much at all.
This was a triumph. I'm making a note here, huge success. It's hard to overstate my satisfaction. Aperture science. We do what we must because we can. For the good of all of us, except the ones who are dead. But there's no sense crying over every mistake. You just keep on trying till you run out of cake. And the science gets done and you make a neat gun for the people who are still alive. I'm not even angry.
Now, Rob with a hatchet.
You broke my heart and killed me and tore me to pieces.